In this video, we're starting our exam 4 review. In this video, we're focusing on Mohr circle and the kinds of questions that often show up on our exams concerning Mohr circle. This particular video is focusing on just terminology. The questions that we often put on tests about Mohr circle are more conceptual. They're simple one-step questions because they're multiple choice. As you've seen, some of the real Mohr circle problems that we work can be quite long. I mean, you're calculating Ix, Iy, Ixy, drawing a circle, writing transformation equations. I mean, they're pretty long. But often we end up putting just conceptual Mohr circle questions on the test that sometimes are worded strangely, or maybe the terminology is foreign to you or unfamiliar to you. And so the purpose of this video and some of these subsequent review videos are to introduce you to basically test style Mohr circle problems. Not necessarily the Mohr circle problems that we worked in homework, but test style homework problems. And so, like every other exam review, you want to be able to see the kinds of questions that are on exams. And so that's the purpose of this review, to introduce you to some of the unique style of, they're short problems, the unique style of Mohr circle problems that show up on tests, that you're prepared, basically, so you're prepared to see them and to work them. Because again, they're different. They're different than what we did in our actual homework and even in the actual lectures. So again, these are terminology you should be familiar with. So cross-section. This is the original area or shape, the actual beam itself, the area. Reference points. So reference points are always the points on the Mohr circle which correspond to the various axes which may exist on the original area. You might see XY, PQ, ST, JK, LM, RS. Don't be confused by that. Let me just show you an example. This is the problem we actually worked. And so if you look at this problem, this is our original area. So this would be the cross-section or the original area. So again, every problem refers to a cross-section or original area. And so that's the beam itself. And this guy usually has an XY set of axes. So that's one set of axes. And then we're often looking for an Imin and an Imax set of axes. So when you get to Mohr circle, the original set of axes plot somewhere on that circle. So you basically have X and Y plotted across from one another. Your Imax and Imin are plotted on the horizontal axis across from one another. And then finally, on this part of the problem, we looked for an arbitrary set of rotated axes. And this is like IU and IV, but you could call this IP and IQ, IR and IS. So those are three different axis systems. They're all at right angles to one another, and they're all at different orientations on the circle. And then finally, if you look down here on this picture, so I didn't label this, but this set of axes is the X and Y. This set of axes is the max and min. This set of axes is the U and V, or the P and Q, or the R and S. So if a problem talks about the cross-section or talks about a set of axes, this is the picture you should have in mind. So again, reference points are the labels on the axes. The principal axes are basically the Imax and Imin. They're the max and min on the original area. I don't always use these terms, but some people do, and sometimes you see these on exams. Is the minor principal axis. And so if you ever see minor principal axis, that's the Imin. That's the same as Imin. The angle from IX to IMin is sometimes called, well, this should be theta, is theta P2. And angles on Mohr's circle are positive in the counterclockwise direction, and they're negative in the clockwise direction. The major principal axis is the Imax axis. The angle from Ix to Imax is theta P1. And again, this says Q, but it should be theta P1. And again, angles on Mohr's circle are positive in the counterclockwise direction and negative in the clockwise direction. So whenever you have these axes, these PQ, ST, IXY, they're always orthogonal to one another. In other words, they're always at right angles. The problems don't always state it, but anytime a set of axes on the cross section or the original area are mentioned, they're always at right angles to one another. Don't be confused by PQ, RS, LM. They're, again, that's just a set of right angle axes. They're right angles on the cross section, and they're opposite from one another on the Mohr circle. They're 180 degrees away from one another on the Mohr circle. And so again, this set of axes, which are again at right angles on the cross section, are across from one another on the Mohr circle, can be rotated anywhere. They're not necessarily at the standard XY orientation. Again, there's generally three axes rotations that are common. First of all, the standard XY, horizontal and vertical. And so about that coordinate system, you might have an IX, an IY, and an IXY product of inertia relative to that set of axes. At some orientation, there will be the principal orientation at theta P from X. And then about that set of axes, you'll have the Imax and the Imin, and IXY at that orientation is 0. Again, we might call that the principal axes. We might call that the major and minor axes, but all of those are basically the max and the min. And then finally, the set of axes can be any other arbitrary orientation. I often call those I, U, and V. And of course, there's a corresponding product of inertia, IUV, at a general angle. As you work these problems, many of them give the center or the average moment of inertia. If they give you that, then that's the center of the circle. Some of the problems give you a radius or a diameter. If you're given the diameter, you can have it to get the radius. And once you have the center and the radius or the diameter, basically that's enough information to define Mohr circle. And then the problem will give you some axis information that maybe it might give you an IXY for that set of axes. And so that gives you a point, and it gives you a vertical distance from the axis to the IXY. Or it might give you the IX value and the IXY value at a point. And so once you have the circle, then the circle basically defines the horizontal axis and the vertical axis and the scale, and then you can locate the point that they give you. This is important. So again, remember that the theta values on the cross section or the original area are drawn as 2 theta on the Mohr circle. So remember, our original set of axes are at 90 degrees from one another on the original area, but they're plotted across from one another 180 degrees apart on Mohr circle. So 2 theta on Mohr circle corresponds to 1 theta on the original area. It just has to do with the math of Mohr circle. So we basically use the 2 theta form of the transformation equations to derive Mohr circle. So read the problem carefully. If the angle is given on the cross section, for example, 30 degrees on the cross section, When you take that to the Mohr circle, double that, and it's 60 degrees on Mohr circle. If the angle is given for the Mohr circle, then it can be used as is on the Mohr circle, but you have to divide it in half when you go back to the cross section. So just read the problem carefully. Is it referring to an angle on the Mohr circle, or is it referring to an angle on the cross section? And so pay attention to what you're reading and respond accordingly. So again, these have just been terminology used in some of these conceptual questions that can trip you up if you're not perfectly familiar with the terms, and connect these terms to the actual picture of a Mohr circle and the actual picture of a cross section. But hopefully this will give you a foundation. And in the next video, we're going to work a number of examples of these simple style problems, again, to get your brain working in this way. Have a good day.